Okay, so we are going to be working on right-angled triangles today. So Pythagoras theorem and then right-angled trigonometry, okay? We did start last week having a look at Pythagoras theorem, but we didn't get very far with it. So I will go back and recap Pythagoras theorem and then we'll work through to right-angled trigonometry today, okay? So move on. Okay, so Pythagoras' theorem, it simply works on this quite well-known formula, a squared plus b squared equals c squared. Okay, so what does that mean? Well, A and B are simply the sides of the two shorter sides of a right-angled triangle, and C always represents the longest side, okay? So the longest side of a right-angled triangle is called the hypotenuse. That's this word here, okay, of a right-angled triangle. And then A and B could actually be either of the two shorter sides. So when we've got a right-angled triangle, okay, I'm going to be drawing it remotely. So I'm going to be editing this remotely today. So you will see, hopefully, me editing it. Yeah, there we go. Okay, so if we've got a right-angled triangle like this, unfortunately doing it remotely, I can't do it quite as neatly as I normally would. There we go. We've got two of the short sides, A and B, and then the longer side is C. Right angle is there. Okay, so that's A squared plus B squared equals C squared. So we square both of the non-hypotenuse sides, add them together, and then the answer is going to be the square root of the length of the hypotenuse. Okay, so we did manage to put that in practice for one question last week. Let's have a quick go at that just to remind ourselves. So the two shorter sides here are 15 and 23 centimeters. Okay, so if we square each of those shorter sides, we've got 15 squared and 23 squared, and we add those together. That's going to be equal to c squared. Okay, c squared is equal to 15 squared plus 23 squared. And then working those out, we've got 225 plus 529. Okay, so typing that in your calculator, this would be a calculator problem. And then adding them together, and then to find the longer side, we must remember to take that square root of 754 there, and the final answer will be 27.46 centimeters. Okay, so one thing that's quite common in exams is students forgetting to take that square root at the end. So if you gave me an answer of 754 centimeters, you just have to think logically. I mean, is it possible for a triangle to have a side of 50 and a side of 23, and then the final side of 754? It's not really possible, is it? So 27.46 seems about right for that longest side. It's just a little bit longer than the other two sides. So that last answer there, C equals 27.46, seems like a good size for the answer there. So that's correct there. Okay. And then we had a look at some applying this into some real life. I'll just erase that. Applying this to a sort of real life problem. Something like this in an exam isn't a typical, it's not an obvious Pythagoras question, okay? So if we have a problem that says a plane flies 120 kilometers due north and then heads due east for 80 kilometers, how far is the plane from its starting point? Well, you might not recognize that that's a Pythagoras problem until you draw that diagram. As soon as you do draw the diagram, you'll see what's happening. You'll see that once you've gone north and then heading east, you actually turn on the right angle to go from north to east. So you've created a right angle triangle there by looking from the starting position to the end point. So we have got a Pythagoras theorem problem there. We know that it's gone 120 kilometers north. We know that it's gone 80 kilometers east. And then if we put that right angle triangle in there, we can work out the longest side. The length of that longest side there is going to be a Pythagoras problem. So looking at our formula for Pythagoras, we've got c squared equals a squared plus b squared. Okay. A and B are the two shorter sides. Doesn't matter which one goes into which one. So we're just going to put 120 and 80 into A and B there. So doesn't matter the order. Could be 120 squared plus 80 squared or 80 squared plus 120 squared. Okay. And then calculating that problem through. So grabbing your calculator and just popping it all in, squaring 120, we get 14,400. Squaring 80, we get 6,400. Adding them together and then taking the square root of that, the distance was 144.22 kilometers. Okay, so that length there, 144.22. Once again, just have a look and check, does your answer make sense? Yes, it's a little bit longer than those two distances, so it does make sense. Okay, if that answer had been less than either of those two distances, you would know you'd made a mistake. Okay, because it's the longest side, so it has to be a little bit bigger. Okay, please do feel free to pop your any questions you have in the chat. I will just keep working through these problems unless you do. I'm just checking now that we haven't got anyone else coming in. Okay, all right. Okay, so the thing that we kind of didn't get onto last week then was looking at finding a shorter side using Pythagoras' theorem. So the formula a squared plus b squared equals c squared can simply be rearranged to make a squared or b squared the subject, okay? So by just subtracting either a squared or b squared, again, it doesn't matter. I'm going to subtract b squared from here, and I'm going to make a squared the subject. I could then use that formula to find the length of a shorter side. Okay, so let's have a look at a problem with that. We've got a problem here. Now we're given the longest side. The longest side is 13 centimeters. And then the shortest, two shorter sides, one is unknown and the other is 12 centimeters. Okay, so popping that into our formula. Now, if we use our rearranged formula, so if you are the kind of person that prefers to remember formulae, you would might want to remember the rearranged formula. So a squared equals c squared minus b squared. Okay, and then popping all that information in. We've got a squared, that's the one there, equals the hypotenuse squared minus the other shorter side squared. And then that gives us 25, and actually square root of 25 is 5 centimeters. So we've got a equals 5 centimeters here. So it's a Pythagorean triple. It's three integers, three whole numbers that square add up to where 5 squared plus 12 squared equals 13 squared. Okay, so that's called a Pythagorean triple, just like 3, 4, and 5, and many other numbers like that, quite famous. Okay. So this is a really sort of typical exam style question using Pythagoras. The size of TV screens are measured by the diagonal distance. Okay, so a 46-inch screen, there we go. It has a height of 30, but it would be a 46-inch screen measured diagonally. So measured from the bottom corner to the top corner there. Okay. So the first thing you would want to do, if you were given the picture of the TV in the exam, like this one here, you would actually probably want to go onto your exam paper and draw that diagonal line in. Okay, so I would take my pen and I would literally draw a diagonal line straight in there, like that. Okay, popping a right angle there. That helps me. I wonder if I can just change the color of this pen. There we go. So that helps me just see what I've done a little bit clearer. Okay, and I've got a right angle triangle there. If you are not given a diagram at all, if you're just told that a TV screen has these measurements, the first thing you need to do is actually to draw yourself a TV screen. You know that the diagonal there is 46, and you know that the height is 30, okay? So you have created yourself a Pythagoras' theorem problem there, okay, by drawing that diagram. So diagrams really are essential in these problems. So now what I'm going to do is I'm going to work through this remotely, so hopefully it's clear enough on my screen for you to see. So I'm actually going to start this time, I'm going to be not so much a formula person. I'm going to start just by remembering the general formula for Pythagoras, a squared plus b squared equals c squared. So not the rearranged one for the shorter side, just the general one, okay? So I know that one of these shorter sides is 30, so I would put that in, 30 squared. The other shorter side I don't know, so I would leave that as b squared, and then I would put my diagonal in as 46 squared, c squared, I know. So I've got my formula written out, but it's not rearranged yet. So the next thing I'm going to have to do is to rearrange it. So b squared now is going to be equal to 46 squared minus 30 squared, okay? And before I even type that into my calculator, I could go one step further and I could take the square root of that. So b is actually going to be equal to the square root of whatever 46 squared minus 30 squared is equal to, okay? So then I would have to grab my calculator and find the answer to that. Please feel free to pop it in the chat if you get it before me. Okay, and I'm getting an answer of 34.87 and so on. So I would round that to probably 34.8 inches. Okay, so that gives me an answer. And then I would just go back and check. Okay, well, that seems about right. Okay, 30 is the height. The diagonal is 46. So yeah, it makes sense for the width to be 34.8, a little bit longer than the height there. Okay, so that was the Pythagoras. I'm going to move on to the trigonometry now. So we did a bit of Pythagoras last time as well. So let me, I need to kind of clear it that. Okay, so right-angled trigonometry. Okay, so one of the most important things in your maths exam is recognizing when to use Pythagoras and when to use trigonometry. They're both used in right-angled triangles, and the key is looking for an angle. Okay, if you see an angle, then you are using trigonometry. If it's lengths only, then it's Pythagoras. Okay, so if you see an angle in your problem, you're thinking, okay, I'm going to my trigonometry rules now, okay? And trigonometry uses 3 functions, and these are called sine, okay? So spelt sine, shortened and pronounced sine, but that's what it looks like. Cosine and tangent, I'm sure you've come across them before. They're all used for right-angled triangles. They are, some of them used in non-right-angled triangles, but we're only going to look at the right-angled triangles problems today, okay? So, before we use them, we need to be able to label the sides of a right-angled triangle, okay? So labeling the sides of a triangle, we have always got the longest side is the hypotenuse, okay? So the hint there is to look for the right angle and then to just label the opposite side of the right angle. So it's the longest side, H or hypotenuse, okay? Labeling your sides is actually a really important part of trigonometry because you need to be able to recognize where your hypotenuse is. Once you've got your hypotenuse, then you can label the other sides by looking at the angle you are working with. So you'll be either given an angle to work with or you'll be given an angle to find. And you take that angle and you look at the sides opposite and adjacent to it, and you just label those, so opposite and adjacent, okay? So I would label them with O, H, and A, or O, A, and H, okay? So if my angle was actually up here, if I was working with this angle, then the opposite and the adjacent would be the other way around, because this side is now opposite the angle I'm working with, and this side is now adjacent to the angle I'm working with. So labeling the sides is really important. You can't really do trigonometry until you understand how to do that. So I was just going to do some quick multiple choice questions. I'm going to work through these really, really quickly. Okay, so here we go. We've got a side marked with X there, and then we have got an angle here. So are we looking at, is X going to be the adjacent, the opposite, or the hypotenuse? I'm going to pop the poll up now and launch that. I'll give you a hint. The answer is not D. Okay, so choose your answer now. Is it adjacent, opposite? Great. Okay. Brilliant. Well done. Okay. And, oh, hang on. Just realised that's in the way then. Okay. Brilliant. Yeah. Okay. It was the opposite. So it was B. So you got that correct. Well done. Okay. So if the angle is now up here, can you see that? I hope you can see that. Maybe that's in. If the angle is now up here in this side, then we're looking at this side here, is that opposite, adjacent, or hypotenuse? Hopefully what I'll do is I'll launch that poll and see. Ah, there we go. I think it was my fault I didn't end the poll. Brilliant. Yeah, correct. Well done. So the answer there was C, adjacent. Okay. Well done. Now, which one is it now? So, okay. So looking now at this one, we have got the, oh, I don't want to say which one it is. I'll give you a chance. Brilliant. A, hypotenuse. Okay, I think you've got this. Excellent. Well done. Okay. I think they do get a little bit harder. Let's find one that's a little bit less obvious. I'll move on. There we go. Which one is that? Is it A, adjacent, B, hypotenuse, or C, B, opposite, or C, hypotenuse? Let me launch that now. Great, brilliant, hypotenuse, well done. So not so obvious, but the key there is to look for the right angle, and it's the one. I'm not very good at the poll today. I might end that poll. There we go. It's the one opposite to the right angle. So let's move on from those and get some actual maths done. Okay, so there are 3 rules in trigonometry. Okay, so if we've got a triangle here and we know now how to label our sides, we've got the angles there, and we've labeled the sides with the hypotenuse, the opposite, and the adjacent, or if the angle's up there, we've labeled hypotenuse, adjacent, and opposite. Okay, then our three rules are that sine of the angle, so sine theta in this case, is going to be equal to the opposite side over the hypotenuse. Okay, the cosine of the angle is going to be equal to the adjacent over the hypotenuse, so the adjacent side divided by the hypotenuse. And the tangent of the angle is going to be equal to the opposite divided by the adjacent. Okay, so in real sort of world problems, the tangent is actually the most useful there. Okay, because quite often we know how high something is, or we want to know how high something is. Okay, and we can work out the distance. So if we want to know, for example, how high a building is, could work out the distance and the angle to the top of that building, and you could find the height. Okay, so tan is quite useful, but then these two also are very, very useful, sine and cosine, especially in further mathematics. Okay, so how do we remember these 3 rules? It's a couple of ways. We've got sine equals O over H, so that's S-O-O-H. Okay, we've got cosine equals A over H. And we've got tan equals O over A. So you've probably seen this many times before. That's what that stands for. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so SOHCAHTOA is something you will have seen many times before, SOH, CAH, and TOH. And in any right angled trigonometry problem you ever have in any exam, I'd highly recommend that's the first thing you write down. Okay, so write that down, and then you can use that to figure out which one of these rules you're using, and then go ahead and do your work. So a few ways some people do remember it using this mnemonic. Silly old horses can't always hear the other animals. I just really like that. But most people will write down SOHCAHTOA in their exam there. Okay, so let's have a look at using them. So the sine ratio. The sine ratio simply states that the angle here, so the angle is always the sine of the angle is going to be equal to the opposite divided by the hypotenuse. So some mathematicians sat down and realized that in any triangle, if they divide the opposite side by the hypotenuse, okay, then the sine of the angle is always going to be true. Okay, so that's what the sine function is on your calculator there. I've just seen a question. Let me have a look. In the exam, will the right angle always be shown? Yes, in my ABCD, they weren't. That's a really great question. Thank you for asking. If you are not shown a right angle, you should not assume it's a right angle trigonometry problem, okay? So if you're doing higher tier exams, you could be working with non-right angled triangles, okay? So if you don't see a right angle, do not assume it's a right angled triangle. So in the exam, if you see a right angle, you're totally safe to go ahead and use your SOHCAHTOA. If you don't see a right angle, you'll be looking at possibly using the sine rule or the cosine rule, which we will be doing next week, okay, in the next lesson. So yeah, really good question there. Always look out for that right angle, check it's there. If it's not there, it could be that the problem is asking you to determine whether or not the triangle is right angled, in which case you could either use Pythagoras or SOHCAHTOA, or it could be almost there as a trick, like, but just check for that right angle before you do it. Other things they may tell you, for example, that you're looking at a rectangle and you know that a rectangle has right angles. So if you're looking at a rectangle and then you split it down the diagonal, you know that's a right angle triangle you're working with. So you wouldn't need to necessarily have the right angle. So there could be a question like that. And another one that's really common, I'm just going to go ahead and just show you, we did some circle theorems recently. And a question that's quite common is, in those circle theorems, one of those problems that we looked at is the semicircle. You know that any triangle in a semicircle is always going to be a right angled triangle. We looked at that circle theorem recently, okay? So if that's a diameter going from, say, A to B, and it goes through the middle of the circle, goes through O there, that's the middle of the circle, then that's a semicircle. So if you create that triangle by joining up the triangle up to the circumference there, then you have created a right angled triangle, and therefore you could use Pythagoras or trigonometry in that triangle. So they wouldn't necessarily have to draw the right angle in there, because you should know that from the circle theorem that that's a right angled triangle, okay? So you should look out for problems where there might, you could see, okay, this is definitely a right angled triangle. And then, but if there's no way of telling it's a right angle triangle, then no, it may well not be a SOHCAHTOA problem, okay? Hopefully that's answered your question. So let's have a look. So the rule we're going to use, if we see an angle and the sides are the opposite and the hypotenuse, then the rule we're going to use is sine theta. So in this problem, we are shown that sine 30 is going to be equal to 5/10. So if you actually type sine 30 into your calculator, it should give you the answer 1/2. If it doesn't, let me know. There are 3 modes on your calculator. In GCSE exams, your calculator should be in degree mode. So there should be a little D at the top of your calculator screen, okay? And that little D is telling you it's in degree mode. So when you type sine 30, it should give you an answer of 1/2. If it doesn't give you an answer of 1/2, it's probably because your calculator is in the wrong mode. It's working in radians or gradient mode, okay? And you can change the mode of your calculator by pressing Shift, Setup, and you'll see number 3 is degree mode. That's the mode you want it to be in, okay? So just press Shift, Setup, and 3, and check that your calculator is in degree mode. Most exam centers will check your calculator before you go in that it's in the right mode, but you should definitely be able to check that yourself. So if you have got any questions about using the calculator, feel free to pop them in the chat and we can talk about it a bit further. But for today, you should have your calculator in degree mode. So sine 30 should give you the answer of 1/2. So I've put 5/10 there because that's the problem, but simplifying that fraction gives us 1/2. So that's the answer, okay? So how would we use this in a problem where we need to find a side? So I've been given the angle 42 and I've been told the hypotenuse is 7, and I want to find the length of this opposite side here. So I've gone ahead and I've actually, put okay, this is opposite, this is hypotenuse, and this is adjacent. oh, look, I'm working with the opposite and the hypotenuse. So I know I'm using sine. So I've gone ahead and done that. And I'm going to write my sine ratio out. Okay, so sine theta is opposite over hypotenuse. Then I'm going to pop the substitute, I should say, all those details in. So 42 is the angle. Sine 42 is equal to the opposite side. That's x divided by the hypotenuse. That's 7. And now I just need to go ahead and rearrange this. So to find x there, I just have to multiply both sides by 7. And 7 times sine 42, I'm going to type it into my calculator. 7 sine 42 should give you an answer of 4.6839 and so on. So you'd round that to 4.68 to 2 decimal places or 3 significant figures. Okay. Any questions on that problem? Check the chat. No. Okay, it seems you're happy with that, so that's fine. I'll keep moving. Okay, so that's for finding the opposite side. It's a little bit easier to find the opposite side because the opposite side goes on the top of the fraction. We've got an extra step when we're looking to find a missing hypotenuse, because when we write out our sine ratio, so when we fill in all these things, this time we've got an angle of 17, we've got an opposite of 10, and a hypotenuse is the side we want to find. So when we've got this problem, the missing side is actually on the bottom of the fraction. Okay, so when the missing side is on the denominator of the fraction, we need to multiply both sides by that denominator. So we've got h times sine 17 is 10, but we're still not able to actually solve it yet until we divide both sides by sine 17. So the hypotenuse is going to be equal to 10 divided by sine 17. Okay, so 2 steps there. Many people just think of it as sort of crossing them over, times by h, divide by sine 17, just cross those over. But just so you're aware of why that works, using the mathematical kind of rearranging that we've learned, h times sine 17 is 10, and then h is equal to 10 divided by, so timesing by h and dividing by sine 17. Again, grab your calculator. These problems are always on the calculator. Oh, actually, you're doing it at Excel International, so generally always have a calculator, don't you? And you should get 34.203, so 34.2 centimeters rounded to 1 decimal place, or 3 significant figures. Okay, so hopefully that's okay for sine. Are there any questions? No questions yet. Okay, I'll keep going. Okay, so cosine is used when we have a hypotenuse and an adjacent given. Okay, so if we have a problem that looks a bit like this, we're giving it an angle, and then we need to either find or use in some way the hypotenuse and the adjacent sides, we're going to be using this rule, the cosine rule. Okay, so we're going to go through our SOHCAHTOA TOA. We'll look for the A and the H. Okay, so the A and the H are in the C, the CAH, CAH TOA. Okay, sorry, CAH, that part. So cos equals A over H. So we can then put that information in. So let's have a go at doing this one. Okay, so we've done that bit. We figured out the rule is going to be cosine. Okay, we're going to substitute the angle in. So cosine of 53 is going to be equal to the adjacent side divided by the hypotenuse. Okay, we're looking to find the adjacent side. So again, it's slightly easier because it's on the top of the fraction there. It's on the numerator. So all we need to do is multiply both sides by 9, and the adjacent side is going to be 9 times cosine of 53 there. Okay, popping that in your calculator, 9 times cosine of 53 is 5.4163. So rounding that to 2 decimal places is 5.42 centimeters. Okay, so generally in the exam, you should round your answer to 3 significant figures unless you're told otherwise. Okay, that's just a general rule for all exams. Okay, so that was finding the adjacent side. Moving on then to finding the hypotenuse using a cosine problem. So if we've got an angle, this time the angle's up here and it's 17. So we can see that the adjacent is this one here, it's 9, okay, and the hypotenuse is the unknown this time. So we can plug that into the ratio there. Cosine of the angle is equal to the adjacent divided by the hypotenuse. Plugging those in, substituting the values in, cosine 17 is equal to 9 over h. And again, we've got the unknown on the denominator. So we're going to have to do that kind of swap trick there. We're going to times both sides by the hypotenuse. H times cos 17 is 10. And then h is 9 divided by cos 17. Now, one thing that I haven't said is once you kind of put the angle on that function cosine, so once you've got this not like cos 17, it's literally just the same as a number. You can treat the whole thing, cos 17, like it's just one single number. So yeah, you can divide by the whole thing just like I've done there, okay? So if you type cos 17 into your calculator, you'll see it is just a number. It's the number 0.9563, okay? So this function, by keeping it as cos 17, it just allows us to have a more kind of exact answer for that value rather than having to round it, because it's a irrational number. It will go on forever, so we would have to round it at some point. You don't want to be writing out all those digits, so it's just easier to write it as the ratio cos 17 as that function, and then leave it there until the last minute when you type it into your calculator. 9 divided by cos 17, and that's equal to 9.41 centimeters. Okay. Why did it change to 10 on the second line? I think that is just my error. Yeah, thank you for pointing that out. I'm very sorry. I don't know why that's changed from 9 to 10. I think that is literally just an error in the PowerPoint there. Quite right, that should have been 9 there, and then 9 divided by cos 17. So very sorry about that. Thank you for pointing it out. I'll change that later. Okay. There we go. Okay. And then let's have a look at doing a tangent one quickly. So using cosine, that should say using tangent when we have opposite and adjacent lengths. Okay. So you can see here we've got the angle of 50, and then we've got a length opposite and a length adjacent. So tangent is easy to spot because there's no hypotenuse. If there's no hypotenuse in the problem, then you're basically using tan. Okay. And tan is the opposite over the adjacent. Like I said, it's the most common one in kind of your real life problems. So if you get a real life problem in the exam, quite often you're using this, especially if the problem involves angles of elevation or depression, you're often using this. So you might have someone standing on a cliff looking out, and then, you know, you're trying to work out the distance of the boat that they're looking at from them or something like that. Okay. But let's have a look at just doing a normal problem with this. So we've got angle of 53. We've got an adjacent side of 11. Let's go through. Okay. And we're looking to find the opposite side. So finding the opposite side. So tan 53 is going to be equal to the opposite divided by the adjacent. That's going to be tan 53 is O divided by 11. And then multiplying up, so multiplying both sides by 11, 11 times tan 53 is equal to the opposite side there. So the opposite side is going to be 14.6 centimeters. Okay, so that's the rule there for tan. And then finding the adjacent is a bit like finding the hypotenuse in the other problems. It's the one where once we've put it into the ratio. So this time we've got an angle of 35. We've got an opposite side of 21, an adjacent side of unknown. So once we put that in, tan 35 is equal to 21 divided by A, okay, divided by the unknown. That is on the denominator then. So we need to rearrange. So we're going to times both sides by the unknown angle, the unknown side A. So A times tan 35 is 21. And then A is 21 divided by tan 35 there. And again, popping that in your calculator, 29.99 apparently. Okay, so that's 21 divided by tan 35 is 29.9911. Yes, so it rounds to that, to 2 decimal places. Okay. So we've done lots of problems. Right, so we're going to look at sort of some problems where we don't know what the ratio is. And I want to work the other way as well. I want to work on finding angles as well. So far we've been looking at being given, in every problem, we've been given the angle. So what happens if we've given a problem like this? Okay, we're told two of the sides of a triangle, and we're asked to work out the size of angle RPQ. Okay, so looking at a problem like this is an exam problem. We're asked to work out the size of angle RPQ. Remember, the angle you need is the kind of letter in the middle, goes from R to P to Q. So it's this angle here in between 17 and 25. Okay, so when we're doing a problem like this, we're going to need to know, we're going to extend what we know a little bit to the inverse operations of the sine functions, okay? So inverse operations are just opposites, basically. The inverse of multiply is divide, the inverse is plus is of adding is subtracting, and the inverse of squaring is square rooting. So the inverse of sine, cosine, and tan, you may have come across them. They are on your calculator, and they are literally just written as sine inverse, cosine inverse, and tan inverse. On your calculator, most calculators look a bit like this. It's kind of an old calculator now, but it's pretty similar to what you're likely to have in your GCSE. And they are these ones above the sine, cos, and tan buttons, okay? So to use them, you need to press Shift and then the button you need. So Shift sine, Shift cos, or Shift tan. So you just literally press it and to find that, okay? So inverse of sine is written sine to the power of -1. It's just sine inverse. So I just would say sine inverse, okay? Inverse of cos is written like that, and inverse of tan is written like that. So let's have a look at using the inverse problems then to find an answer here. So first thing we need to do in a problem like this is actually to label the sides. So we don't know which ratio we're using right now. So we're going to find the right angle, which is there. So the first thing we'll label is the side opposite the right angle. That's the hypotenuse H there. So I'd put an H there. Then we're going to find the angle we're working with. And I would just go straight opposite and put an O, because that's the opposite side, and an A. So once we've labeled the sides, okay, then we can sort of go to our SOHCAHTOA and we can see which one we're working with. So we can see we've got an angle, and then we've got the side opposite and the side adjacent. Okay, so we're working with the function tan. So we'd write that down now. Tan theta is equal to the opposite side divided by the adjacent side. Tan is equal to O over A. That's the TOA part of your SOHCAHTOA. Okay, so tan is equal to 5 over 9. Now, we need to actually use an inverse tan to find the angle. Okay, so to find the angle, we're going to take tan inverse of both sides. Now, tan inverse of tan theta is just theta, so you can just get rid of the tan there. That's the point in taking the inverse. And then to find the angle, we're going to type tan inverse of 5 over 9. Popping that in your calculator, so you're going to press Shift tan, and then put that 5 over 9 into your calculator. And you should get an angle of about exactly 29.054 and so on degrees. Okay. Any questions on finding an angle? Okay, I'll move on. There we go. So rounding that to 29.1 degree. Okay. Again, always round your answers to 3 significant figures, or angles, usually 1 decimal place, but it does normally make it 3 significant figures. Okay, so let's have a look at this problem. So PQR is a right angled triangle. PR is 17, PQ is 25, and we're looking for the size of angle RPQ. Okay, so that's this angle here. Okay, so the first thing you should probably do on the diagram is draw the angle in that you need. All right, so in fact, I will do that. I'll go in and I'll draw the angle in I need, and then I'll label the sides. So my right angle is here. So this is my hypotenuse. Then the angle that I'm working with is this one. So this is my opposite, and this is my adjacent. Okay, so now I can see that I'm working with the A and the H. So going to my SOHCAHTOA, SOH, well, it's not the O and the H, CAH, yeah, it's the A and the H. I needed my cos equals. So I'd write cos theta equals adjacent divided by hypotenuse, and then I can go ahead and put that information in. So cos of RPQ is equal to 17 divided by 25. Take the inverse of both sides. RPQ then is equal to the cos inverse of 17 over 25. And putting that into your calculator, you should get 47.1563 and so on. Okay. Rounding that then to one decimal place is going to give us 47.2 degrees. Okay. So hopefully you're starting to see how these work. Okay. I'm not going to do loads more problems. I'm going to do, I think we've done a few now. So let me just get rid of that writing. Oh, no, that's not right. Making it worse. Okay. Here we go. This is what I wanted to do, some more sort of different style exam questions. So you can see that this question is actually part of a bearings question. So we've got a diagram drawn for us. Town B is 4.5 kilometers due west of town C. So there we go. We may actually, there's a chance you could be given this kind of problem without the diagram. You'd have to draw the diagram in. So remember, due west is always going to be at a right angle heading. So from town C, due west is always going to be heading at a right angle at 270 degrees from there. So this way. And then town A is 2.4 kilometers and due north of town B. So there it is. So gone north to get to A there. So you may have to draw that kind of diagram in yourself. So you just want to put, what would you want to do? You'd want to start by putting town C in and then think, okay, well, west, so northeast, southwest, west is in that direction. I draw a line that way. Wouldn't have to be exactly 4.5 because we're not measuring anything. We're just doing calculations. So it's just a kind of estimate. And then going north 2.4 kilometers, just drawing that diagram in so you've got something to work with for your calculations. And then calculate the size of the angle marked X. Okay, so it really is just a trigonometry question here. Okay, a SOHCAHTOA question. We've got the opposite side. Oh, I can give you a chance to sort of have a go at it if you like. Okay. So the first thing you should do is you should start by drawing or writing in your where your hypotenuse is. So your hypotenuse is always the one opposite the right angle. And then the opposite side and the adjacent side. Well, here's the angle. The angle is X. So we're going to go opposite that. That's going to be the 2.4 is the opposite. And the adjacent is that 4.5. Okay, so we've got that. We're going to now look, okay, well, I'm working with an opposite and an adjacent. So it's definitely a tan problem. Oh, we've got a chat. Oh, fabulous. Brilliant. Yeah, correct. Okay, well done. So we've got tan X equals 2.4 divided by 4.5. Well done. Okay, great. And so then we've worked out that ratio. So we've got that first sort of mark in the bag there, okay, or maybe even 2 marks. Now we need to work it out. So we're going to work out what X is by taking that tan inverse of that problem, 2.4 divided by 4.5. Really, the easiest way is to just type it into your calculator exactly as you see it. Just remember to put those brackets in. Your calculator will probably do the brackets for you. So shift tan 2.4 divided by 4.5. Use the fraction button if you can. Close the bracket and pop in the chat for me. If you've got your calculator there, pop in the chat for me what you got. You may not have a calculator, in which case you won't be able to. No, okay, no worries. I am getting X to be equal to 28 0.0724. So yeah, so popping that just directly into the calculator should give you that. And then you can round that to, and if you're not sure, you can always have a look at the question. Each thing is rounded to one decimal place there. So I'm going to do the same, 28.1 kilometers. Oh, no, it's not. It's an angle. So it's not, sorry, degrees. Okay, there we go. 28.1 degrees. Okay. I think we've got time to do one more problem, and I've just got the perfect problem for it. So I'm going to clear all those drawings. And once again, if you haven't got a calculator, you might not be able to work this through, but do sort of have a look and just think, how am I going to get for a question like this? The diagram shows a triangle A, B, C. Okay, so we've got this bigger triangle here. The line CD is perpendicular to the line AB. Now, you asked the question earlier about, will the right angle always be shown? In this problem, they wouldn't necessarily have to show the right angle there because they've written CD as perpendicular to AB. And so that tells us, and if they hadn't drawn the right angle there, we would go ahead and put a right angle in there because perpendicular means that they meet at right angles. So we'd go ahead and pop a right angle in there, and that would help us really solve this problem, okay? Because we'd be able to now start working through it. Okay, so we know that AC is 2.8 centimeters. We know that DB is 3.5 centimeters, and the angle CBD, that's this one, is 38 degrees. Calculate the size of the angle marked X. So we're looking to calculate the size of this angle here. Give your answer correct to one decimal place. Okay, so they've told you how to answer it. So without a calculator, you won't be able to do the whole thing, but do feel free to pop in the chat sort of what the first step would be if you'd like. And I'll start working through it in just a moment. This is not going to be a one-step problem. I'm sure you've worked that out already. This is a two-step problem. We need to do two things. Oh. Yes, good, great. First problem is going to be to calculate CD, okay? So we're going to go ahead and we're going to work just with this, this triangle here, BCD, okay? So I'm going to go ahead and I'm going to pop in, well, on my BCD, that's H. I'm going to put it quite small there because it's only H on the BCD. Ooh. There we go, okay? So that's H. And then what is CD? Well, CD is opposite and DB is adjacent. Okay, so that's a tan problem then, isn't it? So we're going to calculate CD, okay, by using tan 38 is equal to CD. I'm going to just write CD there over the adjacent, which is 3.5. Okay, so CD is going to be equal to, in the chat, pop the, you don't have to pop the answer, but pop the thing that you would type into your calculator for me. What would you have to type into your calculator to find CD there? Brilliant. 3.5 multiplied by tan 38. Okay, so that's correct. And that will give you, so 3.5 times tan 38 is going to be 2.73449, and so on. So CD is equal to that. We're not going to do any rounding at this point, okay, because we don't, that's not our final answer. So we need to work with kind of a lot of decimal places in that part. But now that we have CD, we can actually find the angle X there, okay? So if you want to go ahead and type into the chat what you'd need to do next to find the angle X. Fantastic. Okay, so X is in this corner here. So that is actually still the opposite, and now 2.8 has become the hypotenuse because this is the right angle now. So yes, it's going to be sine of X then is equal to the opposite side divided by the hypotenuse, which is 2.8. The opposite side we know is 2.734499. So as you don't have your calculator, I'm going to leave that as 35 times tan 38 divided by 2.8. You can do that, or you could write it as sine X equals 2.734499 and so on, divided by 2.8. And then you can type that into your calculator. Okay, so the answer then is going to be X is equal to sine inverse of all of that, 2.7344, all of the rest divided by 2.8, and I'm running out of space there. So we'll find the answer. I've just kept that into my calculator. So I'm actually going to use the answer button. So I'm pressing sine inverse, and I'm going to put my fraction in. I'm going to use my answer button and then divide it by 2.8. So using that answer button, it stores that whole number into my calculator, and then we'll bring that out. So I'm getting an answer of X equals 77.582. So I'm just going to erase this last bit so that I can write that in. X equals 77.582, and then the question asked me to round it to one decimal place. So 77.6 degrees. Okay. All right. And we're just coming to the end of our time. We've got this 7:25 now. So do you have any questions before I stop the recording? Have any questions that you think might be useful for the recording today?